So today we're going to discuss reagents which can be used to synthesize aldehydes and ketones from various substrates. Okay, so the first one that I'm discussing over here is called Jones reagent. Now, knowing the name and also what the reagent has is important. Jones reagent is basically sodium dichromate inside concentrated sulfuric acid, the preferred solvent being acetone. However, one should remember that this is a very powerful oxidizing agent. Okay, so it is used to mainly oxidize 2-degree alcohols to ketones. However, on treatment to 1-degree alcohol, at the initial step they will be oxidized to aldehydes, which further gets oxidized by this reagent to acids. So that is why we are not using Jones reagent to oxidize 1-degree alcohols to aldehydes. However, a modified reagent is used, which is known as pyridinium chlorochromate, also abbreviated as PCC, the solvent here being dichloromethane, or abbreviated as DCM. CrO3, which is the anhydride of chromic acid, is treated with HCl with pyridine, and that results in the formation of pyridinium chlorochromate. The structure of this particular anionic moiety is tetrahedral. The reaction is also called Suggs oxidation. So Jones reagent, as I said, will be oxidizing 2-degree alts to ketones, but 1-degree alts to aldehydes, which further gets oxidized to acids. But if you use PCC, then 2-degree alts will be going to ketones, whereas 1-degree alts will be going to aldehydes. So it is a milder oxidizing agent than in comparison to your Jones reagent. Another reagent that is used is called pyridinium dichromate, abbreviated as PDC, and the structure is something like this. So you can think that instead of sodium, we are having 2 pyridinium ions. Okay, and so such a reagent can be used inside organic solvents. whereas sodium dichromate needs to be used in aqueous medium. Okay, that is the only difference as you can think of. It has a similar function. 2-degree ols goes to ketones, whereas 1-degree ols goes to aldehydes. Another variation that we can think of over here is known as Collins reagent. Okay, which is basically an adduct of pyridinium with chromium trioxide. Okay, so this also functions similarly. It will convert 2-degree ols to ketones and 1-degree ols to aldehydes. But none of the reagents of these reagents can oxidize 3-degree ols. The reason being, it has no CH bonds. Okay. A question that may ask in IITs, which is about the rate of oxidation, which is dependent on obviously how many hydrogens are there attached to the carbon. 1-degree ols have maximum hydrogens, whereas 2-degree ols have lesser amount of hydrogen, and 3-degree ols have no hydrogen. Interestingly, aldehydes are oxidized faster than 1-degree ols. Another method by which we can oxidize alcohols to aldehydes is by using manganese dioxide. It is mostly used or applicable for selective oxidation of allylic, benzylic, acetylic alcohols to the aldehydes or ketones. Okay, so now let us take some examples and try to test the theory that we have already practiced. So suppose I have given you a alcohol like this, or a simpler one like this. As you can see that this portion is your allylic position, so obviously if you're using MnO2 in presence of dichloromethane, this particular molecule will be oxidized to your aldehyde. Similarly, the above one also is a allylic alcohol. Okay, so this also will be oxidized by MnO2 to produce a ketone. Okay, so now if you're trying for systems like this, as I've said, this is benzylic, so also this will be oxidized, importantly, a benzaldehyde. Let us check a few more. Now if you're using MnO2, then obviously the one that is allylic, which is the one on the top, this is the allylic position, but this one is not. So this will be oxidized, whereas this will not be oxidized. Okay. Now, the same molecule, if you're using PCC, please understand, this is also a secondary alcohol, this is also secondary alcohol. So secondary alcohols are oxidized by PCC to give you ketones. Okay. Let us take another example. Say I have given you this one, and you are using MnO2, presence of DCM. Then both the alcohols, this one is primary, but this one is secondary. This is secondary and this is primary. Okay, but both are allylic alcohols, hence they will be oxidized, and the product that you will get is this. If you are using PDC, then also it will be oxidized to aldehyde, and the second one to ketone. Let's try a few more. I've given you this one, and I've given you this one, and I have said use PDC, and in other case you use MnO2. Okay, I've given you this one, and I've said use PCC, PDC. In other case, I have asked you to use MnO2. So here a ketone will be formed. Similar product will be given by PDC, but this alcohol is not an allylic alcohol, so for MnO2 there is no reaction. Okay. Next, suppose I've given you something like this and something like that. And I've said use Jones reagent. Okay. Now, since this is a primary alcohol and this is a secondary alcohol, primary alcohol will be getting oxidized to carboxylic acid, whereas the secondary alcohol will be going to ketone. But if you are oxidizing the same molecule using pyridinium chlorochromate or PCC, then this will be going to as aldehyde, and that will be giving you the ketone. Same molecule if you use Collins reagent, then also you are going to get the same product as you got in the case of PCC. Okay. The other procedure by which one can produce aldehydes and alcohols is via dehydrogenation of alcohols over copper, say at 300 degrees centigrade, or Ag using the same temperature. Just remember, the word is dehydrogenation, so removing hydrogen is oxidation. Okay, so here primary alcohols will go to aldehydes, okay, and secondary alcohols will give you ketones. Now you want to visualize how this is happening, so let us take one example just to illustrate what I'm trying to say. So technically this is your primary alcohol, and suppose this is an alkyl, some R. Now once you are dehydrogenating, that means you are removing two H atoms. So I'm just marking the H atoms that you are removing. You're technically removing this atom and this atom. Okay. And once you remove, there is a development of a double bond over here. All right. So that gives you R, C double bond O and H. Apply the same logic to a ketone. Say again, you're removing this hydrogen and that hydrogen, and the resultant molecule you're getting will be a ketone. That is all you need to remember and apply. Now let us make a small table to summarize what we have learned so far. Okay. Now over here I'm giving you a reagent, given you substrate which is a 1 degree alcohol, then you have a 2 degree alcohol, given you 3 degree alcohol, allylic 1 degree alcohol, allylic 2 degree alcohol. Okay, and say I'm giving you the first reagent, which is PCC. Second reagent is PDC. Third is your Collins reagent. Then we have Jones reagent. We have MnO2. Okay, I've given these reagents. Now 1 degree alcohols, if it is, so I'm saying this is giving you aldehyde, which I have abbreviated as A. These ones will give you ketones, which I'm abbreviating as K. Okay, so for PDC also 1 degree is giving you A, 2 degree is giving you K, Collins gives you A, giving you K, Jones reagent will give you acids, second degree will be giving you K, but none of these will be oxidized by MnO2 as they are not allylic. None of the reagents will be affecting 3 degree alcohols, so we say minus or negative. Obviously PCC will be giving you alpha comma beta unsaturated aldehydes, and these will give you alpha comma beta unsaturated ketones. Okay, and same will happen for PDC, same will happen with the Collins reagent, same result will be happening with MnO2. Okay, now G, synthesis of aldehydes, ketones from geminal dihalides. See over here, suppose you have Cl and Cl. When both the halogens are joined to one carbon, they are called as Gemhalides. Gemhalides, they undergo substitution reaction in presence of aqueous alkaline hydroxides to give you gemdiols, and gemdiols are unstable, so they easily lose water and subsequently they produce aldehydes. Okay, we take some examples for the above reaction.